Hello, algebra students. This is lesson 12.8, last one of chapter 12, and it's choosing a data display. So by now, in your math careers, you have seen all kinds of graphs. So here's just a little summary of all of them. I'm not going to read every single one to you, or I might. Not word for word, but we'll kind of sum it up here. So you've seen pictographs. They use pictures to show the data. A bar graph shows me categories of data. A circle graph or pie chart shows me part of the whole amount. A line graph shows how data changes over time. Histogram, I have number ranges and the bars touch because of those intervals. Stem and leaf plot, it orders the data and it shows me how they're distributed within a range, but I can still see the little individual values. Box and whisker plot, the cutest one of all. That shows variability of data sets using quartiles. It basically shows me the median really, really well by looking at it. With a dot plot, I can see the number of times each value occurs, and it's a lovely visual if I'm looking for the mode especially. And a scatter plot, this shows me a relationship between two sets of data using the ordered pair, so this lets me see the correlation of data. So each graph kind of has its own specific use, something that's special about it. What I want you to be able to do after today is, if I give you a situation, determine which graph would be best to use in this situation. So take a look. It says to choose the appropriate display for the situation, and of course you need to justify your answer. You have to prove it. You can't just say this one. You have to say this one because. So if I have the number of students in marching band each year, think about this on a graph. The number of students, that's the thing that I'm counting, so that would be my Y. And each year, that would be what I would know before. So I might say in the year 2000, how many students were there? In the year 2001, how many were there? In the year 2002. And what I'm hoping you see is that the X is a unit of time. And if you look over at all of your explanations of the graph, there's a specific graph that says it shows how data changes over time. Do you know which one? That is right. It's the line. So I would use a line graph for this. And here's an important word, because it shows data over time. I think when you're doing your homework for this assignment, you're probably going to want to have that lovely little list out in front of you to help you out. Okay, take a look. The next one. A comparison between people's shoe sizes and their heights. Shoe sizes and their heights. Okay, so with this one, I'm comparing two different variables, right? I want to compare them. There may be a relationship, there may not. But basically, this one, do you have it yet in your head? Read through those descriptions. I would want to use a scatter plot for this. I would want to use a scatter plot because I'm trying to determine if there's a relationship, right, between two variables. Well, actually, no comma. Scatter plot because I am trying to determine it's early in the morning. Sorry for all my spelling. Trying to determine if there is a relationship between X and Y. What do you think? Do you think there's a relationship between people's shoe sizes and their heights? We could find that out in class. Be ready for that one. That'll be a fun one. Okay. Letter C says the population of the United States divided evenly into age groups. Okay. So picture this. We have the population, right? That would be what I'd count. And then we have age groups. And when you have age groups, we'd probably say, people in their 20s, 30s, 40s, 50s. Those are age ranges, aren't they? Which graph is great for showing ranges? Now, I know that a stem and leaf plot would show ranges as well, but and show me the individual values. I think if we were making a graph of the population of the United States, that a stem and leaf plot would not be good because you'd be writing values forever and ever. There's just lots and lots of people. So I don't need to see the individual values. I just need to see the grand total. So hopefully I've procrastinated enough and you say histogram. And the reason I would use a histogram is because it's used to show ranges. That's why. It shows me intervals. It shows me age groups. Any of those would be fine. Okay, here we have the percent of students in your school who speak Spanish, French, or Japanese. Now, I know these are categories. We have Spanish, French, or Japanese, right? So we could make a bar graph of this and show the number of people that fit into each category. But if I want the percent of the students, I'm asking you for what part out of the whole amount. Hopefully pie chart is shouting out at you, or circle graph. I don't care which one you call it. Circle graph, pie chart. I would use that one because it shows parts of the whole. In other words, pie charts are used to give me that percent. And we're almost done. I'm going to talk a little bit more about what newspapers and different things will do to you to kind of mislead you in things. I'm sure that you've all seen graphs in the newspaper or graphs that have been displayed. And I don't know if you realize that sometimes people try to display data to make it appear the way they want it to appear. I know it's hard to believe because everyone in the world is so loving and peaceful and kind. But yes, there are people out there that will try to mislead you. It's crazy. So take a look. I have box office receipts, two of the same graph, and over here I have total receipts, billions of dollars, total receipts, billions of dollars, the same amount of years going on here. One of these graphs is misleading, okay? And one of them, not so much. So take a look here. If we're trying to determine what's misleading, this is the same data that's being graphed here, right? Same exact data. Why does this line look like it's straight and this line looks like it's going up? What do you think? They made a break here and they stretched it way out to make it look like it's really increasing at a fast rate. But if we're just between 9 and 10, almost 11 here, that's not really that rapid of an increase. So this is the one that would be misleading because it makes it look like there's a rapid increase. But there's not really. There's not a rapid increase. There is an increase, but it's not like, wow, that's super fast. Okay, another one here. This is a good one. I think you'll see this a little bit more often than the other. So the moral of the last story was pay attention to the number scales. Okay, a volunteer concludes that the number of cans of food and boxes donated were about the same. Is this conclusion accurate? So here's the cans of food, here's the boxes of food. They both look like they ended almost the same amount. Are they about the same? The answer is no. Each one of these items represents 20 of it, right? These cans are a lot smaller than those boxes. So the cans are 20, 40, 60, 81, 20, 40, 60, 82, 20, right? So 220, here there's 20, 40, 60, 80, 120. Because these boxes are so much larger than the cans, it appears that they're about the same even though they're not. So the conclusion is not accurate. Is the conclusion accurate? No. And the problem is that the boxes are larger than the cans. So that can also be something that misleads you to think. So pay close attention, take a look at what kind of scales they're using. All right, now take a look at this one. It says explain why this data is misleading. Here are concert ticket prices. We have rock band A, rock band B, rock band C. Why is this misleading? What do you think? Well, do you see how the ticket size changes? Yeah, these tickets are a lot larger. If you're looking at this number scale, these are only $5 more. And these are only like maybe about $7 more than that. But they make it look like there's this gigantic change when you get to see. So this is misleading because the tickets are not the same size. And the last one, kind of along the same lines here, we have company profits. Now when you're looking at the company's profits, here's 10, here's 15. These are all within this one small little range here, right? So it's not really going up a tremendous amount, but doesn't it look like it's increasing a lot? Why do you think that is? Because they keep making the bars wider and wider as you go to make it appear like they are profiting a lot more than they really are. So the problem with this is the bars become wider. So pay attention to the size of each item if you see a graph like this. And again, in class, I'll show you a few more. We'll try to figure out the problem with it. There are graphs out there that aren't misleading, that are perfectly acceptable. We'll pay attention for those too. I'll see you tomorrow.